So today we're going to focus just on isosceles triangles and equilateral triangles. So yesterday we reviewed that isosceles triangles have at least two sides congruent. And then I did actually share this first rule with you. It's called the base angles theorem. If two sides of a triangle are congruent, then we know the angles opposite them are congruent. So here's my isosceles triangle. So what the rule is saying, that the two angles opposite will always be the same measure. And if you remember from yesterday, these are called our base angles, hence the name base angles theorem. Now, the converse of that, which means we're just going to reverse that rule, starts by talking about the angles. So if in a triangle, you know that two angles are congruent, then we know the sides opposite them will be congruent as well. So if I recopy those two congruent angles and I draw arrows to the sides that are opposite those angles, those would be my two congruent sides. All right, so you have to pay attention. It's not always the left and the right. All right, it has to be the angles and the sides that are opposite each other. So let's look at a couple. Whoops, not yet. Let's talk about equilateral triangles. So if we apply this to equilaterals, there's that word corollary again. Remember, it just is a rule that easily follows. All right, so if a triangle is equiangular, then we know it has to be equilateral. And then if a triangle is known to be equilateral, it's also equiangular. All right, so if I just start with an equilateral triangle and I know all three sides are congruent and I apply the base angle theorem, all right, knowing these two are congruent means these two angles will be the same. If these two are congruent, then I know those two are the same. And you end up marking it with three equal angles. And if we reversed it and started with the angles, we would mark it with three congruent sides. Okay, so just always keep that in mind. The other I want to remind you is that all the angles in an equilateral and equiangular are always 60, 60, and 60. All right, so now let's look at some examples. The first one, when you look at this problem, you should notice right away we're working with an isosceles triangle. So across from those sides, these are the two angles that will be the same. All right. Now, notice that's why they're both marked with M. In a problem you get today, if only one of the problems is marked with a variable, you can put that variable in the other angle. You need all three angles in order to solve, because we know that M plus that 26 all have to add up to be 180. It can't be just two angles. You must know all three. So we've got 2M plus 26 equals 180. If I subtract 26, this up a little bit, I'm going to get 154. And then divide by 2, we're going to end up with 77. All right, so M would be 77 degrees. Notice in number 2, what we're given this time are the three sides. There is not a rule that says the three sides add up to be 180 degrees. In fact, that makes no sense. Side lengths can't be degrees. So we have to look, and we've got these two angles that are congruent. So only the sides that are opposite those two angles are the ones that are going to be set equal to each other. So all we know is that 2x minus 1 equals x plus 7. So you won't even use the x minus 4 at all. So if I solve this, I'm going to get x equals 8. All right, so we want to make sure we grab the correct, congruent sides. Notice number 3, it is marked equilateral. All right, so that means that all 3 sides are going to be the same. So very easily, I can see x is just going to equal 10. All right, not 10 degrees, it's not an angle measure. To get y, I can now set y plus 3 equal to 10, and then solve for y. So y will be 7. Okay, so there's a few examples of how to use isosceles, triangles, and equilateral with solving problems. All right, you should be ready to practice.